Alright, so today we're going to talk about complex numbers or imaginary numbers. Before we even do the definition, let's do just first the visual. So what does it actually look like? So we're going to talk about a function f of x equals x squared plus 1. So if I were to graph this function, before I do anything about solving and anything like that, I'm not even going to do an xy table, I'm just going to go ahead and graph this. Oops. I'm just going to go ahead and graph this. Right now, we know that this is going to be a parabola, and it's going to be upside up because the x squared is positive. And then this plus 1 right here we know that means it's shifted up 1. So this parabola is going to look a little something like this. Okay, so that's the graph of the parabola. And so what I want us to notice is that does this function right here, does this have any zeros? So does this have any x-intercepts? And that's the question, right? And as you'll notice, obviously, it never crosses the x-axis. You can see where I've got the x-axis here. This was our x, this was our y. And the graph, that blue parabola, never crosses the x-axis, which means it does not have any x-intercepts, okay? So that means, because it has no x-intercepts, that means that the solution to the function set equal to 0, or if you want to think of that as called zeros, okay, we take our function x squared plus 1, set it equal to 0. That's how we would try to find x-intercepts if there were any. You can go ahead and subtract 1 from both sides, take the square root, and you're going to get x equals plus or minus the square root of -1. Now, because this never crosses the x-axis, so it's never actually touches the x-axis, it never has an intercept. That's why these are called imaginary numbers. Okay. So that's sort of the reason, sort of the beginning to it. Of course, we could talk all day about the story of imaginary numbers and complex numbers, but let's go ahead and just jump into to the definition, so that way you guys can have that set aside. Okay, let me get that. Okay, so let's first talk about the definition of what a complex number is. Sorry, it just kept cutting off. Okay, so the definition right here. So the square root of -1 is defined to be the letter I. Okay, that's by the definition, right? Another thing that we have is that I squared is defined to be -1. Okay, so those are the main things that you have to keep in mind. That right there is what we need to know leaving this class. Okay, so that's the definition. And then the other thing that we want to talk about then is that what a complex number is. So a complex number is something that's written like a plus bi, okay? And now here, there's two different parts. A does not have the I attached to it, so that's called the real part. B does have the I attached to it, and again, remember I is the square root of -1, so that's what's called the imaginary part, right? So there's a real part and an imaginary part. So for example, some complex numbers, a lot of them, we can talk about them for a while, but some complex numbers would be like 3 plus 4i. That's one example of a complex number. Or maybe 5 minus 2i. Or maybe we can make that even a little bit more complicated. What if I were to do just 7 plus 0i? That's also a complex number. It just happens to be the same thing as 7. So these are ideas of what complex numbers are. So let's just do a couple of examples of how we're going to work with some of those complex numbers. Couple of things that you want to think of is when you're multiplying and simplifying these out. So for example, let's do 2 plus 5i, and let's multiply that by 1 minus 2i. Okay, and this is a multiplication. When you're adding is a lot simpler. You just combine like terms. But for multiplying, it's just one step trickier. You have to multiply all the terms. So the 2 times the 1, then the 2 times the -2i, 5i times 1, and the 5i times the -2i. All right, so that's our goal. So first of all, the 2 times 1 is 2. 2 times -2i would be a -4i. 5i times 1 is a positive 5i. 5i times -2i, well, 5 times -2 is -10. And then I times I, just as if they were x's, becomes I squared. And then we have to go ahead and simplify this, so just be careful. Anytime you see an I squared, by definition, you get to replace that with the -1. every time you see the I squared, you get to replace it with a negative 1. So this simplifies even farther. So 2 minus 4i plus 5i, and this becomes a negative 10. Now it's a negative 10 instead of an I squared, it's a negative 1. And then we just simplify this. This becomes 2, negative 4i plus 5i becomes just plus 1i. Now this becomes a positive 10, negative and a negative. And then we finally get 12 plus I as the final answer. Okay, so that's how you multiply complex numbers. Let me do one example then of where we're going to divide the complex numbers as well, so you can see one of each. So what if I were to do a division? Let's do 2 minus I all over 3 plus 4i. That's now I'm dividing these complex numbers. Okay, so the way you divide complex numbers, really simple. It's always going to be the same thing. It's going to be what you call the conjugate. Okay, and so what is the conjugate? In this case, you're only going to look at the conjugate of the denominator for just a second. So take a minute and look at the denominator. The conjugate is very simple. All you do is change the middle sign. Okay? That's it. And whatever you do to the bottom of a fraction, you have to do to the top of a fraction as well. Oops, that's supposed to be a 4. There we go. Sorry, 4i. Okay. So whatever you do to the bottom, you do to the top as well. So that's what we're talking about here when we say conjugate. And so that's how you're going to divide complex numbers. So you're going to have to simplify top and bottom separately, and that's the goal for here. You're going to want to simplify top and bottom, each one separately. So if I were to look at the 2 minus I, I'm going to look at just the top. The 2 times the 3, okay, that'll give me the 6, and so on. The 2 times the negative 4i, and so on. Okay, and then we just continue to simplify each one along the way. It looks like on top I ended up with 6 minus 11i. This I squared, remember, turned into a negative 1, so that'll become a negative 4. On the bottom, it looks like those canceled, and I get 9. Again, this I squared turned into a negative 1, so I got a plus 16. So I ended up with 2 minus 11i all over, and then the 9 plus 16. 25. Ta-da!